Well, Dr. Arthurs, thank you very much for coming to visit us here today on Light Matters. First, I wanted to ask you about the Great Recession. It's affected every area of the global economy over the last 5 years, and photonics is no exception. Can you tell us about any particular areas of the industry that are emerging and doing well versus others that might still be struggling?
I think that overall photonics is outperforming the economies of the developed world, which are having a fairly tough time actually getting back to decent GDP growth levels. I mean, 2%, or Europe would wish for 2% overall, I think, is not a really robust emergence from this Great Recession. And photonics, I think, is performing better than that, the photonics industry in general. Some of the EU's latest projections for photonics are for about a 6.5% growth rate in the photonics industry through 2020. SPIE's projections are a little more modest than that, largely because so much is dependent on the economies of the developed nations, and we project about 4.5% growth in the photonics industry for the next several years per year. But projecting, of course, is always there's no science to it. Our estimates are based on what we see for the recovery from this recession, which so far each year has started off with more optimistic numbers, and then as the year winds on, they have been sort of modified down to this sort of 2% level, which is a little dejecting actually. But photonics will outperform, we believe, and it has been for a number of years. In fact, if you look back at the history of the photonics market, it didn't go down as much during the Great Recession as many sectors of industry did. Yes, I think parts of it did, particularly the manufacturing sector and lasers in manufacturing, metrology in manufacturing. They suffered pretty badly in 2009. But other sectors, the consumer sector, perhaps at the time we were seeing this huge explosion in screens of different kinds, which are a very big part of the photonics industry. And of course, through it all, Moore's Law, the photonics-enabled Moore's Law continued to underpin the semiconductor industry, where we've seen computer devices increasingly sophisticated. Your smartphone is so photonics-enabled, and there's so much photonics goes into manufacturing it. And that explosion took place to sort of mitigate, I think, the overall effects of the Great Recession on our community.
Now, with any technical field, finding skilled labor is always a concern. What is the demand for photonics professionals, and what's being done to boost the supply?
There's big arguments about whether there are too many STEM graduates, not enough STEM graduates in the US. I think this needs a lot more study, and some of it may be the mismatch of skills to the need. We hear from people in our community that they have difficulty recruiting people with the right skills. We hear the same thing in Europe actually, and we hear that perhaps the emphasis on PhDs, research PhDs in somewhat esoteric technologies is not necessarily meeting the needs of the industry. I think it needs looked at also how we're training graduates in general. There is a tendency in academia to train people for academia, including many of our brightest and best graduates. So the question about whether people are getting the right skills for a life in a fast-changing industry, and where the skills that the industry is seeking are perhaps somewhat different than in-depth subject matter expertise. Rather, the skills to acquire information, the skills to problem solve, the skills to work in teams, and for many of us, the skills to really be a global thinker, that they're not necessarily being provided at this time. So that's one aspect of the problem. But we do see in the developed world a reluctance of young people to come into the hard sciences. They have perhaps been spoiled. There are opportunities that require less intense work through the years of university. And the number of engineers who the number of people who start in engineering, only I think about 50% of those finish with engineering degrees. Some number close to that. The majority finish with degrees, but not with engineering degrees. So there's a huge, it's not a leaky pipeline there, it's obviously a half-broken pipeline. What is doing that? I mean, how can you complain about if they see other opportunities? But we have to improve engineering teaching. We have to also communicate more the excitement about what people can do in science and engineering. Yes, some of these other careers may offer a short-term, financially rewarding experience, but engineers are changing the world, and the opportunity to participate in that is not being communicated. It's been presented, I think, and there's too much drudgery being taught in our engineering programs, not the excitement and the world-changing potential for the young people participating there. And I've met many, many people who've been quite successful in financial world and accounting and things like that, and more than a few have said, you know, I really wish I'd stuck with science, because what I'm doing is earning me a living, but it's boring as all get out. And they envy people who have really been able to participate in science and the rapid change in the world that science is bringing about and can bring about. So I think communicating the excitement of and the potential and what you can do with a scientific background is important, and we're not doing it well enough. We're missing out also on huge sectors of our community. The numbers of women, half our brain power, more than half now probably, who are participating in science are still abysmally low, and perhaps if anything turning down a little bit. And the number of many of our communities, some of the rapid growing communities in our nation, like the Hispanic community, their participation and contribution to science is really not where it should be. Why is that? No role models or no tradition? We don't know, but we need to do something about that.
Well, speaking of communicating the excitement of the field, what can you tell us about the most exciting, interesting new technology with real-world applications on the scene today?
I think some of the medical applications, imaging, actually our tie is about medical imaging here, but it starts with the original X-ray image by Röntgen all those years ago of his wife's hand. And where medical imaging is today is more the top of the tie. The potential for technologies like optogenetics, with this big interest in the brain, which is regarded by many as the next scientific frontier, and programs in the US, in Europe, and in Asia, I think the power there of imaging, but more perhaps the potential for optogenetics to bring about changes, perhaps is enormously exciting. I think one of our very rapid adoption communities in photonics is the people who are in the eye doctors of various kinds. I mean, if you go to their clinics now, you see relatively recent technologies like optical coherence tomography instruments actually measuring everybody's eyes in clinics all over the country, in small towns and big towns. They're rapid adopters. And with some of the technologies that are being provided to eye doctors, the potential that for the eye being actually the window to the brain is very, very exciting, I think. I suspect that in a few years you'll go to your eye doctor and expecting to come away with a prescription for new lenses, and you might come away with a warning about early signs of diabetes or something like that, or some warning that would allow you to perhaps to change your lifestyle to set back some years the onset of some of these diseases. I think there's enormous potential there with the technologies that people can use now looking into the eye.
Well, Dr. Arthurs, thank you so much for visiting us here today.
Thank you. It's a pleasure to be here.